Okay, so I've handed out to you guys the comprehensive sort of checklist skills that you need to make sure you've mastered. And if you've mastered all these skills, then you get 100% in the test. That's the plan. So we're going to have a read through of them. I've referenced where they occur in the textbook. We're going to go down the bottom there. We've got the chapter review set questions that are relevant for the test. So you see I've removed some of them, but all of them can be a revision resource. And then over the back here, this is what we're going to work through today to recap chapter 5, 6 and 7. So we're going to go through all of that together. You might be able to squeeze it on this sheet, but I probably recommend trying to just writing it a bit neater in your book so you're not really squeezing it in. So we're going to go through this first, and then I've got for you the practice test, which I'll hand out. And that's up to you how you're going to use that, whether you use it, sort of next week sometime, dedicate a whole lesson to it, or whether you just use it as a revision resource. It's up to you. I'll hand it out. And then after today's lesson, we've recorded it and stuff, I'll send an email, detailing all of the things for the test, these kind of attachments, playlist, and so forth. I think that's pretty well it. So test Thursday next week. That's when it is, unless you want to do it Tuesday. Speak to me individually. Okay? All right, so let's get straight into it. Firstly, it's a big unit because we've got chapter 5, 6 and 7. 6 is quite short. We only spent a week doing that. And there's quite a strong relationship between chapter 5 and chapter 7. So it's important for you, go through, check off the skills that you feel you're pretty confident with. And then if you're not sure of what something means, ask me. I'll point out in the textbook what it corresponds with. But there's the checklist. Let's move on from that. Let's get straight into the questions. So we've got first up, convert the following to the opposite form. Okay, so if we're given an angle in degrees, its opposite form is going to be radians. And so we can look, I'll point out in your notes book, maybe you've probably already seen this already, but on the second to last page, okay, there's a summary of formulas, right? We're not providing you with that. If you want them, you can put that on your cheat sheet. But first one, top left, from degrees to radians. So we've got 70 degrees, and we want to follow the arrow because we're going to radians. We need to multiply it by pi on 180, and that's just something we plug straight into our calculator. All right, 70 times pi on 180. Evaluate it. We're going to have 7 on 18 pi. So I'm going to talk about the answers that pop out. 7 on 18 pi can't be simplified. So if you put that in, so 70 times pi on 180. All right, we've got 7 on 18 pi. Now this is a perfectly suitable way of expressing the answer. You could round it, okay, so if I press the S to D button, okay, just above the 8 for everyone, the fraction to decimal button, that's going to convert it to a decimal, all right? But the problem with that is you have to round it, right? 1.221, and so then it rounds to 1.22. And here in this form, it includes every possible decimal place. So when we can, we do like to express answers exactly, okay, because it allows for every possible, it's more precise. All right, that being said, we're going to accept either of these. All right, just type that in your calculator. This is what it spits out. Done. Okay, leave that. Now, degrees, that's the symbol for degrees. C is the symbol for radians. These are worth 1 mark each, right? So we're not going to penalise you if you don't write it, but it's important to get in the habit of using correct notation. Okay, so that's the first one, A. On to B, it says convert pi on 7 into degrees. Okay, so anytime there's pi involved in an angle, that means it's in radians, right? We've observed that. That tells us, anytime there's pi. So if we're going from radians to degrees, we're multiplying by 180 on pi. All right, again, just chuck it straight in your calculator. And it'll spit it out in simplest form as a fraction. So we have pi on 7 times 180 on pi, and we've got 25.71 degrees. 25.7. All right, full marks there. Whatever your calculator spits it out, that's how we should answer it. Okay, let's move on to number 2. Find the arc length and sector area of this sector. So a sector means it's like a portion of the circle, right? It's a portion of a circle. And we're given the angle in radians. So when we look at our sheet here, we've got arc length, and we've got for theta in radians, we've got a formula, and we've got for theta in degrees. So we're looking here, the angle is given to us in radians, which means we need to use the formula involving radians, which is just the angle times the radius, right? Theta times r, the angle times the radius. So the arc length, or we can call it L, is equal to theta r, which is pi on 6 times 5.6. All right, we'll evaluate that to 3 sig figs. 14 on 15 pi, which is 2.932. Now, again, just being fussy with notation, the unit here is centimetres, okay? The radius is in centimetres, which means this arc length, the distance of that arc, is also in centimetres. Okay, for the area of a sector, we've got the angle in radians. The area is half theta r squared. All right, so that's 0.5 times theta's pi on 6, and then times the radius squared. And we'll just evaluate that. Okay, any questions at any stage, please stop me. If I'm going too fast, let me know. So evaluate that, I've got 196 on 75 pi. To 3 significant figures, 8.210, 8.21. Unit for area is units squared. Our unit is centimetres, so for area, centimetres squared. All right, that's question 2. All right, move on. Find and evaluate the following. Okay, we've got sine of pi on 6. There's 2 ways we can do this. You can just, in your calculator, the angle's in radians, right? Pi on 6. And so you can just type in your calculator sine of pi on 6, provided it is set in radians. Now you do need to flip back and forth between radians and degrees, all right? Some of the triangle problems will be in degrees. A lot of the unit circle stuff is in radians. So you need to be able to flip back and forth between the 2 of them. Do you mind grabbing that for me, Kevin? You can get it from your calculator. Just put that in, sine of pi on 6, and you'll get half, okay? The other way we can check it is from the unit circle. And I want us to be really competent at just referring to the unit circle all the time. Here it is. And you go sine of pi on 6. Okay, that means the angle is pi on 6. You find that. Sine is the y value. And you can see the y value listed there is half. Okay, 1 mark question, done. On to the next one, cos of 35. Now you might be inclined to look at your unit circle, but 35 is not one of the multiples on the unit circle. So we can't obtain this one from the unit circle. We need to use our calculator, and our calculator has to be in degrees because the angle's in degrees. Okay, so shift menu brings up all your options. You scroll down to angle, change it to degrees, and we go cos 35. All right, I evaluate that and I get 0.8191. All right, and let's just explain really quickly what it means, right? Here's the unit circle. We're saying the angle is 35 degrees, which will be about there, all right? And cos is the x value, okay? So what it means is for this point here, this is important because it will get asked in this kind of way. This point here, the x coordinate is 0.819. Remember, cos of theta is the x coordinate, sine of theta is the y coordinate. There's some corresponding y coordinate, we don't need to know what it is. All right, How about this one? Find cos of theta given sine theta is half. Now for this one, you can use the Pythagorean identity, but we're going to use that next. Instead, we know that sine theta equals half. That's on our unit circle, all right? And what it means is, I'm going to rub this out and refer to the same circle, okay? What it means is, when the y value is half, okay? So here's the y value, right? Remember, sine of theta is the y value, and we're saying the y value equals half. So here's 0, here's 1, half is here, and we're saying, what are these points on the unit circle? In fact, we are asked specifically, what is the cos value of theta? What is the x coordinate of those points, given the y value is half? So you can look at the unit circle, all right, and you're going, what's the corresponding x coordinate when the y value is half? So bring up your unit circle, okay, we've got here the y value is half. What's the x value? Root 3 on 2. Okay, that's the first one. That's in the first quadrant. Here it is here. The x value, the distance there, root 3 on 2. How about for over here? It's going to have the same magnitude, the same size, but it's in the opposite direction, isn't it? It's negative root 3 on 2. Okay, make sure you can observe that on your unit circle, all right? We've got the y value is half, okay? And the x value minus root 3 on 2. On this side, the angle it corresponds with is 5 pi on 6. Okay, make sure you can see that. If you can't make note of it, let me know. You need to be confident using the unit circle. So to answer this question, if sine is half, all right, then the cosine value is positive root 3 on 2 or negative root 3 on 2. It can take either. And you can write it like that, or you can write two separate statements. Either's fine. Okay, excellent. On to number 4. Now in number 4, we've got sine theta is 3 on 4. Okay, and we've got a restriction of the domain, pi on 2. And we want to find cos and tan. So we're going to do this two ways, all right? Because there's two ways of doing it. The first way is to use the Pythagorean identity, and that's this one, all right? So you'll see that listed in your notes. We learn it in exercise 5C and D. Sine squared theta plus cos squared theta equals 1. We've got sine of theta is 3 on 4, so we're going to take that and plug it in here, right? Sine of theta is 3 on 4, so we have 3 on 4 squared. Plus cos squared theta equals 1. And now it's just an equation that we're solving through to get cos theta by itself. This becomes 9 on 16. We subtract the 9 on 16, we move it over this side. All right, I'm not going to delve into fraction operations now. You can put that in your calculator. So we'll have cos squared of theta is 7 on 16, and then we square root both sides, right? Good? Yes. Root 7 on 4. All right, so I want to talk about that because there's two values, right? There's positive root 7 on 4 or negative root 7 on 4. Now, by the way, I've simplified it by square rooting the denominator, but we're going to still accept that anyway. All right, we will accept root 7 on 16 because we will do surds next semester. We haven't technically gone through those operations specifically, but nonetheless, they do simplify. There's two answers here, but we are restricted to a specific region, right? We're told from pi on 2 to pi. So that means we're talking about this second quadrant. Here's the angle pi on 2, here's the angle pi, so we're talking specifically about this region. Now, because we're in that region, the x values are negative, okay? The x values are negative, which means this is our solution. We reject the positive solution because in this region, cos, which is the x value, is not positive. Okay, so that's how we get the cosine value, all right? And then remember, tan is sine divided by cos. All right, so if we want to find the tan value, we go, all right, the sine value is 3 on 4, and the cos value is negative root 7 on 4, and you can just put that in your calculator, okay? 3 on 4 divided by negative root 7 on 4, that you can do that, get the tan value that way, all right? So that's using the Pythagorean identity, but I want to show you the other procedure because I think most people find the other procedure a fair bit easier. That is when we draw a right angled triangle. We label it. So we've got H, A and O, just a right angled triangle, labeling it with the hypotenuse, the adjacent side and the opposite side. So we're starting the question again, right? We're given sine of theta is 3 on 4. Now sine is O on H, all right? SOHCAHTOA, remember that, sine is O on H. So that means O corresponds with 3, all right? This side is 3, and H corresponds with 4. This side is 4, and we can use Pythagoras' theorem, hence the Pythagorean identity. We can use Pythagoras' theorem to determine the value of A, right? We'd have A squared plus 3 squared equals 4 squared. 16 take 9 is 7, and then we have the square root of 7. I went quick there, so I'll pause and let you catch it.
Is this, what question is this one?
We're still on question 4. Okay. Sine of theta is 3 on 4. So we found the cosine value down here, right? All right, we found the cosine value, and then that's how you find the tan value, because the question says find cos and tan. And what I'm doing right now is just showing an alternative, probably an easier process. In fact, this one I recommend doing because you don't even have to remember the tan relationship. All right. So we've determined this A value is root 7, right? And then all we're going to do is we're asked to find cos. So cos of theta is A on H. A is root 7, H is 4. All right, so we've got the cos value. And then the last thing to do is consider the region. In this region, cos is negative. So we're just going to whack a negative in front of it. All right, we say negative, and then we can reference the region because pi on 2 is less than theta is less than pi. All right, so there's none of that complex algebra involved, rearranging it, considering positives and negatives. We're just looking at the region. And then we go to tan theta. Tan is O on A, SOHCAHTOA. O on A, we'll look at our diagram. O corresponds with 3, A corresponds with root 7. So tan is 3 on root 7. And we go, is the tan positive or negative? Well, we've got to consider the region. This is a good opportunity for me to remind you of all students talk cool. All right, so in this region, all ratios are positive. In this region, only sine is positive. If only sine is positive, that means both cos and tan are negative. All right, because pi on 2 is less than theta is less than pi. So you can see that's a fair bit less working out. This kind of question, it's worth about 4 marks asked to find both ratios. Nonetheless, you can use either procedure. Either is absolutely fine. So whatever suits you best. All right, so that's number 4. Let's move on to number 5. Any other questions so far? All right, so number 5 says evaluate sine 60, cos 30, using the unit circle. So this kind of question is worth 2 marks, right? And this question, we do in exercise 5E, and you could just put that in your calculator, and provided it's set in degrees, it's going to spit out the answer. It's going to give you 1 of the marks, but what we're looking for is the unit circle substitution. So to get the other mark. So you're looking at the unit circle. You're told sine of 60. Sine is the y value. The y value, when the angle is 60, have a look. The y value is root 3 on 2. All right, so we have sine of 60 simplifies to root 3 on 2. Next it says multiplied by, when they're written next to each other, that's what it means, multiplied by cos of 30. Well, the angle is 30, cos is the x value, so cos of 30 is also root 3 on 2. All right, and then you just chuck that in your calculator or do it in your mind. Root 3 times root 3 is 3, and 2 times 2 is 4. All right, so if you type that top sentence in your calculator, and when it's in degrees, that's what it's going to spit out, right? Maybe 0.75, probably 3 and 4. But what we're looking for is the substitution. That's where you get the second mark. Very good, that's question 5. Okay, so what we've done there is reviewed chapter 5. That's what we did first, okay? We started that towards the start of this term. So it's been a fair while away, but hopefully we're sort of remembering the unit circle. Probably the most complex parts of it is substitution, and then things like question 4. And I can point specifically, if that's a skill that you want to practice, there's heaps of them, all right? Question 4 there using the Pythagorean or the triangle process. Excellent. So now we're on chapter 6, and we're going to do all of chapter 6 in one question. We're only going to do this one question of it. I haven't included any problem solving. I just want to cover the skills. Okay, problem solving is a skill you can practice individually, but I'm looking specifically at the process and the skills. So first up, we have this triangle, and we're told find the area and unknown sides and angles of the following triangle. So this is 40 degrees, this is 9, this is 10. Okay, we'll do the area first. All right, that's what we learn in 6a. We've got the area is half AB sine theta. All right, where A and B, they meet at angle theta. So this is side A, this is side B, this is angle theta. So that's going to be half 9 times 10 sine of, our angle is in degrees. So our calculator must be in degrees at this point. All right, 0.5 times 90 times sine 40. 28.9 to 28.9. And for area, unit, centimeters squared. Okay, that's the area. Very good. All right, now let's find the unknown side. And we've got both the sine rule and the cosine rule, right? So sine rule, problems involving 2 sides and 2 angles. Cosine rule, problems involving 3 sides and 1 angle. So let's look here, let's just start with, and it doesn't matter what order we do it in, let's say we're trying to find this unknown side, okay? So we have, if we picture that, we have a problem involving 1, 2, 3 sides, 1 angle. That's going to be the cosine rule, all right? We're trying to find this unknown side. So we'll use the cosine rule. Now, we've got 2 forms of the cosine rule. So flip at the back, have a look. I've listed them both. All right, so when it's written like this, a squared equals b squared plus c squared, take 2bc cos a. That is for an unknown side. And when it's written like this, cos of a equals, that is for an unknown angle. We are trying to find an unknown side. So we're going to use this form. All right, and remember when we label a triangle, when we're using the sine and cosine rule, if this is side A, this is angle A. And then B and C, it doesn't matter because they're in the same relative positions. So these are going to be both B and C. And we'll just put it straight into our formula here. A squared is equal to 10 squared plus 9 squared. All right, so I'm just putting B and C there. Take away 2 times 10 times 9 cos of the angle in between, all right, cos of 40. And so all we're doing is putting that in our calculator and then performing the square root of it, right? Anyone cracked it yet? Make sure your calculator's in degrees. Now, just quickly, you can check. Your calculator does tell you. Right at the top, next to your battery, it says maths, and then it says the angle that you're in. So if you're in degrees, it says deg. If you're in radians, it says rad. All right, so always have a check there. That's what we're putting in. So that's what a squared equals. A squared equals, and it's like 43.11. So then a is the square root of that. So I'm going to just square root answer. I've got 6.565, which is 6.57 centimeters. Okay, so we've used the cosine rule. We've found this unknown side. Okay. Next, all right, so what did the question ask us to do? It said, find the area, find all the unknown sides. So right now we know the length of all of the sides, and find all the unknown angles. So what we're going to do next is we're going to find this angle. All right, and I'm going to call it angle B. And you could use the cosine rule, but I want to use the sine rule because we haven't done it yet. I want to revise that skill in particular. So if you're looking at the sine rule, we have some space here. All right. There's two ways of representing the sine rule, but we'll just start with the one we're going to use. Sine of A on A equals sine of B on B. All right, I write it that way because we have the angle at the top and we are trying to find the angle, aren't we? If we've got this triangle labelled, all right, so we've got this side is 6.57 centimetres, that's what we found. And so we have sine of A on top of A, all right? So sine of 40 on top of 6.57 is equal to sine of B on top of B. All right, remember, if this is angle B, then its opposite side is side B. So that's going to be sine of B on top of 9. All right, and then we're just solving through to get the angle B by itself, right? So we're going to multiply both sides by 9. All right, so there's sine of B. We can evaluate this in our calculator. It's going to be some decimal number. I'm just going to write answer. So sine of B. But we want the value of B, right? So we perform the inverse sine. We do sine of -1 of whatever this evaluates to. I've said it's going to be some decimal number. We can put it in our calculator, all right? And then we do the inverse sine of it, and that's going to give us the value of B. Okay, let's do that. Still in degrees, so we have 9 times.
61.7.
Thank you. Okay, so angle B is 61.7 degrees. So we've found this angle. All right, so we've used the cosine rule, we've used the sine rule. There's only one angle left to find. Now, if you wanted to, you could go ahead, you could do a sine, you could do a cosine rule, but there's a much faster way to get this last angle.
Yeah, 180.
Very good. All of the angles in a triangle add up to 180 degrees. So if we know these two, then we know that one. It's going to be 180, take away both of these. So what's that? 78.3. All right, because all angles add up to 180. Very good. Okay. Now we're on to chapter 7. All right, so we're recapping what we've done most recently. we've got graph the function. Now, I said, last lesson, I said, I do not want anyone to get graphing questions wrong. All right, you're literally copying it off your calculator, so you need to make sure you know how to use your calculator. So we're told graph y equals 3 cos 2x plus 1 from 0 to 2 pi. Now this domain tells us, all right, the domain tells you something very important. Put it in radians, okay? The domain is in radians, so our calculator needs to be set in radians. All right, and then let's start thinking about the V window, right? Let's start thinking about what am I going to set my V window to? Well, firstly, my x min is 0, my x max is 2 pi. All right. Then you go, what about my y values? What do I set my y min and y max as? All right, and remember the foolproof method. All right. Yeah, you roll on, Harry. You'll be here tomorrow? Yeah. All right, the foolproof method is to go, what's the amplitude plus the principal axis? That's the highest it's going to go. The amplitude is 3, the principal axis is 1. You add them together, you get 4. The highest point is going to be 4. Okay? And then the lowest point is going to be the principal axis. Take away the amplitude. That's how far down it goes. So if you put all of those parameters in, that's going to picture it absolutely perfectly. All right? So you get your x, the question's going to give it to you. The question gives you the domain. For your y, it's just a matter of adding the principal axis and amplitude. Okay, so put that in, let's graph it, and I'll show you what kind of thing we're expecting. Firstly, the principal axis is at y equals 1. Here's 0, here's 2 pi. So you can get this from your calculator, but I'm going to justify it to you why I'm sketching it this way. The first thing is it has an amplitude of 3. All right, so if this is 1, it goes up 2, 3, 4. That's going to be its highest point, and that's where it starts because it's a cosine function. All right, a cosine function starts with a peak. All right, so if that's 2 pi, then pi is going to be here somewhere, and its lowest point is -2, isn't it? Now, this function, because we have this number 2 here, that tells us there are 2 wavelengths in 2 pi. So that means it repeats itself twice. All right, if there are 2 wavelengths in 2 pi, that means there's 1 wavelength in pi. So that means it's back up to a peak here. All right, and then it's going to be back up to a peak here. So we have, here's, the minimum is going to be here and here. I'll plot those points and then I'll just sketch it. All right, we can see we've got 2 wavelengths in 2 pi. We've got the amplitude, all right, 3 units there, 3 units there. And we can get all of that from our calculator. All right, so that's for question 7. Okay, state its amplitude and wavelength. Okay, amplitude is always this number out the front. Always make it positive. Amplitude is 3. Wavelength. Okay, 2 ways for the wavelength. You can look at it and see, all right? If we have 2 wavelengths in 2 pi, that means we have 1 wavelength in pi, right? So the wavelength is pi. The other way is that the wavelength, the formula for it, the wavelength is equal to 2 pi divided by b. Always. The wavelength is always 2 pi divided by b. b is this number here, the coefficient of x. So it's 2 pi divided by 2, which is pi. All right, 2 ways of confirming. All right, so that's our wavelength. Wavelength is always positive. Don't be deceived if there's a little negative there. Just always make it positive. Okay, on to number 8. So, yep, graph, get those marks. You absolutely have to. Then on to determine the equation of this sine function. All right, so I'm going to sketch it. We've got here's 6 pi, and we've got a whole wavelength in 6 pi, starting at -1 and going up to 2. 1, and then down to 3. 1, 2, 3. So, and 0. Yeah. 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 All right, so I'm just sketching it so I can point at it and gesture. That's 3 pi. And then they're sort of scattered throughout, right? Okay, so we need to find the equation of this sine function. We're told it's a sine function. So we need to go, what's the value of A, what's the value of B, and what's the value of D? Remember I've said we're not going to give you a horizontal translation because they get a bit messy. So the best one to start with is the principal axis, right? What is the line about which the function propagates itself? Where does it start? Okay, for a sine function, it starts here at -1, and hopefully we can see that's the line about which the function propagates in the horizontal direction. So our value of D is -1. Next we say the amplitude. The amplitude is the distance from a principal axis to a peak or to a trough, okay? That's always going to be the same distance. So if we're at -1, we've gone up 3 units. All right, and if we're at -1, we've gone down 3 units to take us to -4. So our amplitude is 3. All right, we're going up 3 units and then down 3 units. We've got the value of A. Okay, and the last one is the value of B. 2 ways of answering it. The first question is, how many wavelengths are there in 2 pi? 2 pi is like here somewhere. It's really difficult to tell how many wavelengths there are in 2 pi. So instead, we should use the other process. Sometimes you can see it very clearly. Sometimes you can see there's 1 wavelength in 2 pi. Sometimes you can see 2. Sometimes you can see half. This one I've intentionally done a little bit deceptive, so we do the other process. We can't see how many wavelengths there are in 2 pi. You could guess, but it's a bit risky. Instead, use the formula, okay? We can see the wavelength is 6 pi, okay? The wavelength is 6 pi, and the wavelength formula is 2 pi on B. So if we have the wavelength is 6 pi equals 2 pi divided by B. All right, how do we get B? In this equation? We're swapping them. We're going to have B equals 2 pi on 6 pi, which is a third. The value of B is a third. There is a third of a wavelength in 2 pi. All right, so that's how we get the value of B for question 8. Very good. Move on. Question 9, almost done.
Mr. Rose, can I get a drink?
Sure, yep. All right, so question 9, there will be some problems, some trig equations to solve using technology. We have 3 sine x take 2 equals 0 from 0 to 2 pi. Okay, so if you're asked to solve this using technology, the foolproof method, all right? Graph 3 sine x take 2, graph 0. All right, so you're graphing both equations. V window, don't really need to worry about y. You don't need to see it. You just need to G-solve the answers. V window, 0 to 2 pi. So you're restricting the possible x values. All right, once you've done that, it's just G-solve, intersection, and obtain all of the solutions. All right, so if you've got those restrictions, there's y1, there's y2, graph both of them, set your V window, G-solve, intersection, foolproof process, get the answers. 3 sine x, take away 2, 0. and in radians, of course, because our domain is given to us in radians. My calculator is in degrees. Very good. Okay, got there. Okay, we've got x equals 0.729730 and 2.411. Very good. Okay, so that's using technology, all right? That's 7E.2. And then lastly, we'll move on to 7E.3, which is where we solve trig equations using algebra and back to the unit circle, all right? So what we want to do, we've got to solve this over this domain. All right, so the first thing to do is to consider this coefficient, all right? We have to multiply the domain by that coefficient. So this becomes from 0 to 2x to 4 pi. All right, I've taken that number 2 and I multiply the whole domain by 2. Okay, that gives us that statement. Next, what we want to do is we want to try and isolate sine of 2x by itself. So we're going to break it down. All right, so we're just solving a linear equation, trying to get this component by itself. Okay. All right, and then once you've got it so that you've got the trig ratio by itself, you're looking at the unit circle and you're going, when is the sine value, when is the y value equal to half? All right, so think about it. Here's 0, here's 1, half is going to be here, the y value is half, and that corresponds with here and here on the unit circle. So you can isolate where it occurs, right? So we're going to have 2x is pi on 6 and 5 pi on 6. They're our first two answers. Make sure you can see them. All right, make sure you can see. That's where the y value is half. All right, sine is the y value. The y value is half here at pi on 6 and over here at 5 pi on 6. Okay, make sure you can see that. Now, that's correct within one revolution, but let's look what happened to our domain because of that number 2 out the front. It's doubled it. We need to consider not just one revolution from 0 to 2 pi, but another one. That means we're going past these solutions again. We're going past the same solutions again. So if we're going past them, we just need to add 2 pi. All right, 2 pi if we go past it once, 4 pi if we go past it the third time. So we got 0 to 2 pi, and then another 2 pi. Okay, and then you can, I'm not going to go through the fraction operations again, put them in your calculator. So we've got pi on 6, 5 pi on 6, it's going to be 13 pi on 6, and 17 pi on 6. Okay, so all I did, put that in my calculator to get those extra 2 that are in the second rotation of the circle. One more step, we want to get x by itself, so we divide all of these answers by 2. We've isolated x, we've got pi on 12, 5 pi on 12, 13 pi on 12 and 17 pi on 12. All right, really, really good. Any questions? So that's quite a tricky solving trig equations one. If that's a skill you need to practice, go to 7E.3. But everything we've gone over, we've covered everything that we can ask you. So all of those questions are really good. So right now we've got just under half hour left. I'll hand out practice tests. All right, it's up to you where you're going to put your efforts. You've got a cheat sheet to do, we've got practice tests to do, we've got other practice resources once you finish them. We've got the review sets, okay, to have a look at. Hopefully we've finished the exercise. So yeah, all from me. Let's use our time well.